Hey, good morning, everyone. Is my voice audible? Okay, great. So yeah, so again, welcome back. Yesterday, I just gave a quick recap on what we saw yesterday, and then we can quickly jump to today's session. So yesterday we just saw what is time complexity and how to find it and what's the use of it. So basically, given a bunch of codes, you have to find which is optimal. Right? Among those optimal things, time complexity will not help you there. It is up to you to choose those based on your needs. Right. So yeah, coming back, so the time complexity is very important. And one more thing which I wanted to say for time complexity is, so in an interview, right? It's not like you write the code and then get the time complexity. So first you have to freeze on the time complexity and then only you'll be allowed to code. So yeah, the frequently asked question is, if I don't code, how do I know time complexity? So what you should do basically is once you come up with an approach, you should have a not a very clear thing, but at least a vague idea on how you're going to implement it in your mind. And based on that, you should be able to say, okay, my approach is this complexity, right? So yeah, so in an interview, they expect you to tell the time complexity and freeze the approach, and then only because that's the only communication, that's the only way you can communicate the interview, right? So you say your solution is this complexity, he'll say, okay, it's better. Can you think better? Can you do better? So those kind of things. So yeah, so how can you visualize the code? So initially, it will be a bit difficult, but as you solve more problems, you'll be able to visualize, visualize the approach you're seeing. Not completely, but at least the main pieces which will contribute to time complexity, right? The main logic part. Okay, so okay, so how to fix time complexity in case of while loop? Again, right? So time complexity is not specific to loops. So in while loop, if you can somehow find how many operations you are doing and how it is related to the input, then you can kind of come up with the complexity, right? So yeah, so uh, it's not just the loop or something. It's more like how many you have to find how many operations you're doing for a given piece of code. We'll again come back to this. So next concept involves something which is similar to that. But yeah, in that case, we'll see how to find time complexity if it's not a for loop or if it's not a very straightforward case. Right. Okay. So while moving on to the next concept, um, okay. So I'll move to today's concept. We'll see this concept via an example or via problem, so that you guys can better understand what is the use of this concept, right? So it's not a very big algorithm or something. It's more like a technique, but yeah. So from this question on, right? If we see any questions, we'll go in the interview kind of a thing. So what is interview kind of a thing? As I said, right? So first I'll give you. So think of yourself in an interview and saying this question in an interview, right? So we have this pattern, right? So that pattern you can tweak and change based on your needs. But usually, first is you have to freeze the approach. Second is you have to tell the complexity. Third is you have to write the code for the same. So this is the order in which we are going to do. So first question, I'll kind of help you in what all things you have to do and those kind of things. So on second question, let's take it like a real interview. The only thing is I'll be showing the code and other things, right? So yeah. So 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 just assume that 5 minutes into the interview you're setting and you're saying that you're ready for the interview, right? So this is how it goes. So think of me as an interviewer, right? So the question is, you're given a binary array, right? So you're given a binary array of size n. Okay, so you're given a binary array of size n. So for example, this is one binary array, right? So and you're also given the value k, right? So what is this value k? So k will say what is the most number of. Oh, sorry. Thank you for saying that. Okay, I hope the screen is visible now. Okay, so you are given a binary array of size n. Binary array is you can take one thing as one example as this one, and you will also be given the value k. So k says what is the most number of zeros you can make it as one in this array, right? So k says so you can change at most k zeros in this ones to ones in this binary array, right? So say if k equal to 2, in this binary array you can change at most two zeros to ones. So what is at most? You can change up to two zeros. There is no compulsion that you are always change two zeros to ones, right? So given a binary array of size n, and you'll also be given the value k, which says what is the utmost value of zeros, you can change it to one in this binary array. So after changing at most k zeros to ones here, what is the maximum subarray of size one, maximum subarray of all ones that you can get? So what is the maximum subarray of all ones you can get? Right. So in this example, the answer will be, if k is equal to 2, we can change up to two zeros in this binary array. Say I'm changing this 0 and this 0, right? So what is the maximum subarray of all ones available in this array? So this is one subarray, this is one subarray, the size is 2. But this is not the best you can get, right? This is not the maximum size of the subarray you can get. Say if you change this 0 and this 0 and this 0 to 1, the maximum size of a subarray of all ones will be 3, and that will be the answer. So the answer here will be 3 because you can't do better than that. So 3 is the maximum size of the subarray having all ones after changing at most k zeros to ones in this binary. So yeah, subarray is a continuous set of elements in an array. So this is one subarray, this is one subarray, this is one subarray. The whole array itself is a subarray. Subarray is just a continuous set of elements in an array. Okay, so after the question ends, usually the interview will be silent, as I said. So maybe next 3 to 4 minutes, you have to ask questions on what all doubts you have in the question, or if you don't understand the question, you can also ask for one more example or something. Okay, so if the question is clear, if you have any approach, you can also say that. If the question is not clear, you spend the time. If the question is clear, then yeah, you can. If you have any approach, you can say. Okay, can you explain the brute force solution? Please, when you chat, right, anything which is not personal, please chat in everyone so that everyone can get benefited from your ideas, right? So, yeah. So what is the brute force approach? Someone says brute force, but what is the brute force approach here? Okay. Fix the window starting from left till number of zeros in the window is less than k. Okay. So less than k. So first you will fix this. Okay. After that, okay, so I got one more approach saying that we can select first two zeros in the array in order to always give the maximum answer. That's not always right. Say for this example, right? So in this case, if you fix the first two, you'll get the answer only 2. But if you take the last two, you'll get the answer 3. So okay. Okay. So first you'll fix k zeros in the window, right? Okay, less than or equal to k. And this is another approach. If the number of zeros is more, then you remove from the left of the window. So remove as in like you delete it from the window. Uh, remove as in you delete it, or how do you? Okay, so you remove it. If it is less than or equal to k, okay, you remove it. Um, can you elaborate your approach a bit? Maximum number of elements window with at most k zeros. Okay. Okay, so first you fix one window till less than or equal to k, right? So after this, what do you do? Okay, so I'll come back to that approach. Okay, so we have a window, we increase or decrease, and yeah, okay, I get what you're trying to say, but yeah, we'll come back to that approach. So I got one more approach saying that takes a subarray size of 2 with all 0 in between 1. Okay, so you take these, okay, and change to 0. So how are you going to find this? Like between two ones. So there can be a case where there will not be 1 here, but taking this will give a better answer. So yeah, you get the idea. It need not be always between two ones. Okay. So what is the brute force approach here? So everyone knows what is brute force, right? So everyone wants explanation on what brute force means. Okay, no for you don't know, or okay. So brute force is, say you're saying this question to a 5-year-old kid, okay, who doesn't know anything about efficiency, who doesn't know anything about computer science, right? So what is the first solution that came to your mind? Say you want to change at most two zeros to ones in this array, right? So what is the easiest way to do this? So okay, so the easiest way to do this is you change all the combinations of two zeros to ones and take all the combinations. You get the idea? And take all the combinations and then find which is having maximum subarray in this. Meaning, you're just going to try everything, try all the possibilities, and then you're going to come up with an answer, right? So that is the brute force solution, correct? So that is called brute force. Brute force means you don't think about efficiency, you don't think about any approach, you just try out all the possibilities, right? So here, what is trying out all the possibility means, that you can try out various possibilities, right? So you can change up to 2 zeros. So you can change this zero and this zero, this zero and this zero, likewise all the possibilities. So you'll be having a bunch of answers. In those answers, you go through all the answers, find which is having maximum subarray of size 1, and then you return it, right? So that is going to work definitely, because it's a brute force solution and you're trying out all the possibilities, right? Okay. So yeah, so that is called brute force. So this brute force is a good way to understand the question. So if you don't understand the question, you can say brute force approach, and then via brute force approach, you can also understand the question. If the interviewer is okay with your brute force approach, I mean, okay means not like completely okay. If the interviewer is saying that whatever brute force approach you say is working, then it means that you understood the question right. Okay. So yeah, that's also one of the ways. That's like you're being much more efficient, right? So you're also saying on brute force approach, and you're also trying to get the question. So you're trying to save a lot of time there. So yeah, so brute force is also one of the way to understand. So you can just quickly say this brute force approach, maybe in 1 or 2 minutes, so that you understand the question right, and you have some approach in your hand, right? So some approach in your hand which will be useful later, right? So in this question, this brute force approach itself can be much more optimized, right? Uh, right. So what is this? What is the optimizations you can do from brute force, right? So brute force, you try out all the possibilities, right? But should you try out all the possibilities? Okay, so you need not try out all the possibilities. What kind of possibilities alone you have to try out? Uh, okay, so if you see, right, it's been 10 minutes since we started this question, right? So yeah. Uh, right. Okay, so please message in everyone so that everyone can get an idea on what you're thinking. So I think kind of got a thing. So we can traverse the array, and whenever you encounter 1, you just keep it. Whenever you encounter 0, right, you can replace it to 1, and you can think of replacing that 0 to 1. Meaning, what you do is first you start from here. First you start from here. This is a 0, so you make it as 1. This is a 0, you make it as 1. But when you go here, right, k is equal to 2. You're already used 2 zeros, right? So you stop here, right? So this is the maximum subarray you can get at this point in time, right? So this is one of the answer, right? But this is not going to work for all the cases. In this case, it is working, but this is not going to work for all the cases. So let's leave out the approach, right? So why are you saying that in brute force approach, we tried out all the possibilities, right? But in this approach, you're forcing your logic to change consecutively occurring zeros to ones, right? Need not be, it can be something like this too. What I mean is consecutively occurring zeros alone. So you'll be changing only these zeros. You'll not be changing this zero and this zero. You get the idea? So in this approach, you're forcing your logic to change only zeros, one occurring one after the other, right? Not consecutively. There can be ones also in between, but that ones doesn't matter. So what I'm trying to say is you're changing zeros only occurring one after the other, right? It's zero in between, one in between, right? So why are you forcing that?
Hello.
Yeah.
Hello. Am I actually audible now?
Yeah.
Yeah. Actually, it will also work in the case of 1010. In case of 1010, first
Yeah.
we
Yeah.
first we
That's
actually
what I'm saying.
encounter.
So that's what I'm saying. So in 1010 also, say you have these many zeros. So you're always forcing this one and this one, right? So you don't try out the possibility of this one and this one. Why so?
Okay, now got it.
No,
Okay.
no, your answer is correct. But why are you always taking these zeros only, and you are omitting some of the cases? Why do you do so?
Okay, just in this case, if actually k equal to 3, if k equal to 3 and the input is 1010 and 00, and first we encountered 0 in the second place, then we replace it as 1, and after that 1, and after that 0 is coming, that after that we can replace it 0 with 1, then it will be 1 1 1 1, means 4 ones and 2 0.
Right. So I think I didn't make it clear for you, but you're always changing the consecutively, not consecutively occurring, zeros occurring one after the other. You just forget once for now. These are zeros occurring one after the other, and you're always changing that. Because in brute force, you didn't do that, correct? In brute force, you tried out all the possibilities. Like, say, if you want to change two zeros, you would have tried out even this possibility. But in current approach, you're not trying out all the possibilities. You're trying out only zeros occurring one after the other. The reason being is you want maximum consecutive ones. Say if you're, say in this approach, the approach you said, you change this 0 to 1, and you leave out 1 0 in between and change this 0 to 1. So what is happening is you're wasting one unnecessarily, wasting 1k unnecessarily. You could have used that k here and could have made it better. So that's the reason why you're always preferring changing zeros occurring one after the other to 1, correct?
No, actually I don't get you means this.
Okay, so can you explain your approach in this question?
Yeah,
For this question? Yeah.
Yeah. At first we actually encounter 1, and
No,
after
let's
that,
take.
okay,
Okay. Okay.
you can actually give actually another input. So
Yeah, take this input.
okay, the at first we actually encounter 0, so actually we actually change it to 1.
Okay.
And it will decrement by k by 1.
Okay.
So the first one will be 1 and k will be 1.
Okay. Yeah.
And after that we actually encounter 1, so
Yeah.
actually we just increment the counter. And another, after that we encounter 0, so we actually replace it to 1 and increment the k value. And after that we means after increment the counter, and it will be 1. So here will be 4 ones, and we actually store that 4 value in a extra variable called max or something like that.
Okay.
So 4, then after that also 4, then after that it is encountered 0. Encounter 0, then actually we stop that, and after that we move to counter, we move the counter to next part.
So from here you'll again start it, correct?
Yeah.
Okay. So what I'm trying to say is I understood the approach, your approach earlier too, but you're forcing your logic to always change zeros occurring one after the other to 1, right? Why is that so? You get my question?
I got your questions.
Yeah, so that is correct. But in the interview, they'll ask that question, like, why are you doing this? So you should have a proper justification. So I think someone gave a proper justification in the comment. Because we want maximum number of consecutive ones. Say you are not using this approach and leave a 0 in between, right? Say you just change this 1 and leave a 0 in between and change this 0 to 1. So what is happening is this exists as a separate entity, this exists as a separate entity, right? This is not going to help you because 1k is getting wasted here, 1k is getting wasted here. Rather, if you had used this 0 to 1 here, you could have used these 2k's efficiently, right? So that's why always changing consecutive zeros is better. Consecutive means zeros occurring one after the other.
Okay.
There can be one in between, but you get what I'm trying to say.
Yeah.
Okay. So yeah. So is everyone clear on why this is better than brute force and why changing consecutive zeros is better? Is everyone getting that point? So that is actually really important. So that is going to reduce your brute force into some workable solution, right? So this is definitely a workable solution, correct?
Hello.
Yeah.
Yeah, hi. I have an approach like why can't we start zeros and ones? First zeros will arrange and then one. So we change the
You want
last to zero.
you want sub array, right? So if you sort, you lose the array, right? You lose the ordering. You should keep the ordering intact, right?
Okay.
Hmm. Okay, so is everyone clear on this approach? Like you start from zeroth index, you go till right, it's possible. So what is possible here? Whenever you encounter zero and if there is a k available, you mark it as one and go right side. Whenever you encounter one, you just add it to some counter or something and you go right side, right? And whenever you can't, it's not possible, you stop there and keep that solution as one of the solution. Then you start from the second index and do so. Then from the third index, you do so, right? So you'll be getting a bunch of values. And among these bunch of values, you can just take the maximum and then return it, right? So that's what we are going to do here. So why will it work? Because in this case, we are assuming that we will change only the consecutively occurring zeros to ones. And why that always works? Because you want maximum consecutive ones in the answer. If you leave out a zero in between, then you're going to waste k, right? You're not going to efficiently use k. So is everyone clear on these 2 points? Like what you're going to do here? Okay, so this approach will work, right? So will there be any issues in this? Okay, so is everyone clear on this approach? How to decide till which position should be iterate? Till you have a k to be burnt out, or till you reach the end of the array, whichever is occurring first, right? So sometimes what can happen is everything can be one, so you will not even use all the case, right? So that case is till the end of the array, or there can be cases like this where you exhaust all the case, right? So k mean exhaust all the k value. So here it was zero, then here it was two, then you made it as one, then you made it as zero. So whenever you are trying to make k as minus one, you stop, right? So till that point, if you see, you would have gone till this point. When you went there, k would have become minus one. So this is the answer at this when you start here. So when you start here, you'll again reset the k equal to 2 and do the same. So you'll stop when you exhaust k or when you reach the end of the array, whichever is occurring first. Okay. So what is the time complexity of this approach? Yeah, so there can be multiple answers. So you need not give the answers. You can just give what is the maximum size of the subarray. You get the idea. So the question was, in the first case, there can be multiple answers. You get the idea, right? It's not the there can be multiple answers. You only want the size of the answer. Yes. How is it often? Okay. So whatever complexity you say, you should have a proper justification of the same as well. K is not constant. K can vary, right? K can be 10 power 5 also. So whenever you're representing some complexity, if k is involved there, you have to include k as well. Or k can be n square also, right? You don't know. So you have to include k as well. K can be n square, obviously. K can be n also, right? The entire array and all the array can be 0. So yeah. Okay, so can anyone explain how you got this O of n? So every index you start and you go till you can exhaust k, correct? Every index you start and go till you exhaust k. So to see every index itself, it is going to take n time, correct? And you're going to exhaust k values, right? You're going to exhaust k values, but the size of the array need not be k. It can be more than k as well. Meaning, say if k is equal to n by 2, okay? K equal to n by 2, right? So even if everything is 0, every time you will be going at most n by 2 times, correct? Maybe n by 2 times, n by 2 minus 1, n by 2 minus 2, n by 2 minus 3, something like that, right? So n into this value, right? So you get the idea, right? So it's definitely not O of n, because every time you are starting here and going till it's possible, correct? And next index also you're going to go there and go till it's possible, right? So definitely it's not O of n. So what is the complexity here? And again, right, you don't go right side k times, because depending on the number, you can take less or more, correct? So there can be only two zeros, but there can be like 1,000 ones in between and then two zeros. Just because there are two zeros doesn't mean that you go only two places, right? You go 1,002 places, right? So yeah, so definitely not O of n. It's much more than that. Yeah. So what is the complexity here? So this is more like n plus n minus 1 plus n minus 2 plus we saw, right, yesterday. This is more something very similar to this. Yeah, maybe it need not be always here, but think of a worst case, right? So worst case, this can happen. So what you do is you start from the first index and go till the last. Then you second index and go till the last. Third index and go till the last. Fourth index and go till the last. So it will be n plus n minus 1 plus n minus 2 plus till 1, right? So yesterday we saw this pattern, right? So what is the complexity of this summation? So can everyone visualize what you're going to do, and what is 1 plus 2 plus 3 plus? Oh, okay. To find the sum, it's O of 1, but you have to traverse, right? So you can't do it in O of 1. You get the idea? If you want to find the sum of this, then it's O of 1. You can use mathematics, but you don't want the sum here. You have to actually traverse the array, right? These many times. Yeah, you get the idea. So it's not just finding the sum of this. It's actually these many times you're going to iterate through the array, right? In the worst case. So if you iterate through the array these many times, it will be O of n square, correct? Because it will be n into n plus 1 by 2. Then after simplifying, you'll get O of n square. So is it clear, like what you're going to do here and why it's n square? So whenever you say complexity, you should have a proper explanation on why you are saying so. Right. Anyone wants the explanation on how I got the complexity? Okay. So what you're going to do is every index you're going to go right till it's possible. So what is possible here? Possible is you exhaust either k or you reach the end of the array, whichever is occurring earlier, right? So whichever is occurring earlier, right? So say for example, first time you go till the end of the array, right? So it will be n. Next time you go n minus 1 times. Next time you go n minus 2 times. And the last time you will go only once, correct? So these many times you will be seeing the entire array. So what is this? This is n into n plus 1 by 2, correct? So what is n into n plus 1 by 2? This is O of n. Sorry, O of n square, right? So n into n plus 1 by 2 will be n square by 2 plus n by 2. And after applying, you'll remove this 1 by 2 and n by 2, then you'll be having O of n square. So is it clear? So ideally you are seeing the array in terms of n square times, not exactly like n square, but you get the idea, right? Okay. Any doubts in this so far? Okay. So okay. So first we had a brute force solution. Then we had an optimized solution. How did we come up with an optimized solution? We found out one observation. So what is that observation? If you take the zeros occurring one after the other, it will always give the better answer. So that is the observation, and that's how we optimize. So this optimized approach is having O of n square. Correct. So usually, right? Usually in an interview, most of the times the question you'll be saying for the first time, right? Very rarely you might have known that question, and if you know that question, the interviewer also know that you already seen that question, right? So even there you'll try to make the question difficult or change the question, right? So what I'm trying to say here is, if you have a very proper story, right? So this is a proper story, right? We had a very bad solution, then we optimized it. How did we optimize? We saw an observation. Subconsciously we had that observation. If they ask why did you come up with that observation, why are you forcing that, you should have an answer. So once you have an answer for that, you found the complexity of that to be O of n square, right? So you came till this part, right? So after you say this approach, the interviewer will say that, can you do better, right? So can you do better? Meaning there is a better solution than O of n square, right? So right now, whenever you are stuck in this phase, so the only thing is, in our previous approach, we are doing something unwanted or something extra. So if you can somehow store that, or somehow use that, or somehow keep track of it, then the complexity is going to reduce. So then again, you go and see the question. Okay. You go and see the question. You get the idea, right? So if you have a story like kind of a thing in an interview, it means that, okay, you're always thinking about optimization, and you're always thinking logically and about the question, right? So that's why if you have a good story, like what you're going to do, then it will be easy, right? Say you already have the efficient approach, you can also directly come to this efficient approach. But if it is a new question and uh, you are very new to that question, and you're thinking it for the first time, then there is no compulsion that you have to directly come to the efficient approach. You can go to a little optimized approach, okay? And then based on the optimized approach, you can find out what is the issue with your little optimized approach and then make it more efficient, right? So this path also you can follow. As long as you have time, you can follow either of these paths, right? So yeah. So coming back, so this is a question you had, say k equal to 2, right? So what, we'll just see how the code is going to go, okay? So first time you'll go till this part, till this point, and you stop here, correct? Because once you stop here, k will become 3, but you can take only 2 zeros, so you stop here. Second time you start here and you stop here. Second time you start here and then you stop here, right? Third time you start here and stop here. Fourth time you start here and stop here. Fifth time you start here and stop here. Sixth time you stop here because you reach the end of the array. Seventh time you stop here, right? So what is it that we are doing again and again? So what is the issue with our approach? Okay. So take this piece, this part alone, right? So you see, right, how many times this part is being seen again and again, right? Okay, so you get the idea, right? So if you see, these zeros and all is getting visited again and again. So you already know that there is a zero here, right? So why do you want to come back and then see these zeros again? Meaning, you already saw this zero when you first iterated this and you stopped here. You again came back and you're starting here. So what I'm trying to say is, if you already know how many zeros are there, two places before that, why two places? Because this guy is done, right? So you went till here, and in this place you saw this is the best I can do. Okay. Then next time when you started here, it means that this guy is not all needed after this. So what I'm trying to say is, when you stopped here, right, you need not come back and start again everything, because these zeros and all, you already know that there is a zero. So if you can somehow keep track, right, there is 1 0 before it, and this is the second zero, right? So if you somehow keep track of it, it will be easier, right? So you get the idea, right? So you're visiting same zeros again and again. So if you can somehow store it somewhere, then it will be easier for you. Is it clear? Is the issue in our approach and the solution we are proposing clear? How we are going to do this, we'll see, but you get the idea, right? So somehow we are going to do that. So what is it somehow, we'll see. So is it clear, or should I explain anything? So we are visiting same zeros again and again. So if we can somehow store it or somehow do something, then it will be easier, right? So I'll just clear this and we'll take one proper example, okay? So I'll just take this example. 1 1 1 0 0 0 1 1 1 1 0. Okay. So k equal to 2 here. Okay. Right. So what I'm going to do is, first I'm going to see only this part. Okay. So I'm going to see this part. So whenever I see a small part of it, so this is one subarray. It's meaning I'm going to see one subarray, small subarray at the start, and I'm going to increase the subarray I'm going to see as and when as and when it's possible. If it's not possible, I'll just try to make the array better and then start saying again, right? So this was approach someone told at the start, right? So I'm just reiterating it. But why I didn't want to come to it directly is, as I said, right? So it's not solving this question; it's about the thinking process. So now you have a proper. I hope you have a proper thinking process on how to break down problems into simple. So this is what I told by breaking down problem into simpler pieces. You need not always go to the efficient approach. At this point in time, you find something efficient. If it is not the most efficient, you again optimize it. You again optimize it. You again optimize it. So that's how it goes, right? So coming back, so this is a small subarray you're going to try. Okay. So is this subarray a potential answer? Why not? So say this is the answer I'm proposing. Is this answer a valid answer? I mean, it may not be the actual answer, a valid potential answer. Meaning, if you take only this part of the array, or am I changing more than 2 zeros to ones in this part of the array? Right. So I'm not changing more than 2 zeros in this part of the array. So which means this is a potential answer, correct? So what is a potential answer? This can be one of the answer, right? So what I'm going to do is, I'm going to, I just saw this one, okay? So this part of the array alone, right? So this part of the array alone I saw, and I found out that, okay, this part is a valid one, right? Or at least a valid one need not be the answer, right? So we need not worry about the answer now. So since it is a valid one, what I'm going to do is I'm going to become greedy. So what I'm going to do is I'm going to add one more value to the right. Okay. So I'll come back to this greedy algorithm, right? So it's not an algorithm per se. It's just a way to do a few things, right? So in this case, it's a greedy algorithm. Why means I'm becoming greedy, right? So greedy means first I saw with one value, it was didn't become content there. I want more answer. So why do you want more answer? Because I want to find the maximum number of ones, right? Not just. So I go and see these and the value. So right now, like a valid potential answer, or is it a favorable case? Why not a favorable case? So in these two values, are you changing more than two zeros to ones? So is my voice audible? Right. So you're not changing more than two zeros to ones. Right? So this is one of the valid potential answer, correct? So when I say potential answer, it may not be the actual answer, but this can be actual answer, right? So you get the idea. So what I'm trying is, whenever I have a valid case, I try to increase the size to the right side. So whenever I have a valid case, I increase the size to the right side. So now I have first three values. So if you take first three values alone, is it a valid or not valid case? Right. So first three values are also valid, correct? Why means you're not changing more than two zeros to ones, right? So when you take the next value, right? When you take the next value, now you have 1 0 in the window, right? So whenever you have a 0 in the window, you assume that you're going to change the 0 to 1, right? So now is this window valid or not? Right. So now again it's valid, correct? So every time it's a valid, what do? You become greedy. So what do you do by becoming greedy? You go right side, right? So now this is a valid thing. So is this a valid or not? Right. So now also it's a valid thing, because if you see, the number of zeros is only 2 and you can take up to 2 zeros. Great. So now when you go right side, is it a valid or a not valid window? Right. So it's not a valid window anymore, correct? So what happened is you became too much greedy and now you are in a fix. So what does being in a fix mean is, uh, you don't know what to do next, right? So the next step is you have to somehow make this window valid, correct? So how do you make this window valid, right? So if you see, right, if you start here, right, if you start here, the best answer ends here, correct? The best answer ends here, correct? If you start here, the best answer ends here. Why means after that it's uh, becoming not valid, correct? So if you start here, the valid answer ends here, correct? Meaning after this point, after when you reach this point, these three zeros are not at all useful, right? So how do I say that? Right. So right now you are in a fix. So you are having three zeros, but you can change only two zeros. So at this point, what you do is you just try to reduce the size of the window from the left side. Okay. Reduce the size of the window from the left side. So now is it valid or not? Again, it's not a valid thing because you have three zeros, but you can change only two zeros. So again, you reduce the size of the window from the left side. So again, is it a valid one or not? Right. So again, it's not a valid one. Right. So now you take out this zero, right? So now is it a valid one or not? Right. So now it's a valid one. Why means you can change only two zeros to ones. Right. So whenever it's a valid, what do you do? Yeah, you become greedy, right? Which is you move to the right. Correct. So you move right side. So you get one more one. So again it becomes a valid. So you move right side, right side, right side. And when you go here, you stop. Right. Which means till this point, it's going to go right side because everything is becoming valid, right? So in this case, what do you do? This is a not greedy case, correct? Because you are having three zeros in this. You can become more greedy. So what do you do in this case? So you have 3 zeros, you can't do anything. So what do? You move the left side, correct? Right. So why do you reduce from the left? Because the zero is not all needed anymore, right? Why it's not needed means if you include the zero, the best possible ends here. Since you are going to try for the next one, this possible the zero is not all needed anymore because it's not zero is not going to contribute to you in any way after this. The zeros, what I can say is the zero's life ends here, correct? Once you see this zero and this zero is not at all useful anymore because the best this zero can do is only this till this point, which means the zero's death happens once you see this zero, right? So meaning this zero is not needed, so you let go of that. So once you let go of that, you'll be having one more window. So now it's a favorable case, right? Right. So now it's a favorable case, right? So right now, whenever you reach the end of the array, you stop, right? Because there is no point in going right side. So you ideally should have gone right side for this case because it's a favorable case, but you can't go right side, so you stop. So this is the last window you'll be seeing, right? So so this is the approach we are saying, right? So if you see, this is called a window, correct? So this is called a window, and if you see, whenever what we did was we just put the window here and then increase the window, decrease the window. We didn't put the window back again. So first, meaning we put the window here. We put the window here, right? Right. But again, we don't come back and put the window here, right? We reuse the same window by reducing or increasing, right? So can everyone understand why this approach is better than the previous approach? Because in our previous approach, we again and again went back in time and put the window. But here we have only one window and we are just going to increase or decrease the size of the window based on the input, right? So which means it is much more efficient than the previous approach, right? And second thing is this window you are having, right, is going to slide through the array, right? So in a previous case, you kept the window at every instant, but in this window there is only one window and we are going to slide through the array. So that's why this approach is actually called a sliding window approach, right? So sliding window approach, right? So I got one question: why didn't we stop before the last zero? Unless we see the zero, we don't know it's a zero, right? So only if you go and say this it's a zero, we become it as a we know that it's a zero. Because if it is a one, then you can take that one, right, to increase the answer. So yeah. So only when it is not possible, you stop. Till it's possible, you just move around. Right. So this is why it's called a sliding window approach, right? So can everyone understand why this is better than our previous approach? So in previous approach, we went back in time again and again. So here we are just, adding an element, removing an element, adding one element and removing an element and going to slide through that, right? Okay. Okay. So what is the time complexity of this approach? Is it better than the previous one or it's the same as previous? Okay. So actually in this approach, right, the way you implement can either make it n square or O of n, right? Which means this approach, the way you implement, if you leave any if you don't optimize it properly, it can become n square. I'll say why. Okay. If you have a subarray itself to store the window, right? Say you have a separate array to store the window itself, right? Say this is the initial array and you have one more array which is going to store the window, right? Then whenever it's a possible case, you add it to that window. And whenever it's a non-possible case, you remove it from the array, right? So this adding and removal can be O of n in itself, correct? It's not always O of n. It's like randomized, it's better, but still it's O of n. If you go and see, right? If you use shift and all, right? So shift and all is O of n. So shift is nothing but removing the first element, right? So if you do this kind of an implementation where you actually have an array and add element, push elements and shift elements, those kind of things, then it's going to be O of n square again. Because every time you do O of n operation and you do for every element, so it is going to be O of n square. But you need not actually have an array. Why means, so why do you have an array? Because you want to get the size, you want to see the size of the array, right? But you know that the given array, the input is a binary array. So you know that the given input is a binary array. So in a binary array, binary array means the array will have only ones or zeros, right? Or only two values. In this case, it's 1 or 0, right? So in a binary array, say you know the size of the window, right? Say here the size of the window is 6, right? And you know the number of zeros, 3. So how to get the number of ones? So this is the size, this is the number of zeros. So what will be the number of ones? It's a binary array. It can have only 1 or 0. Right. So s minus number of zeros will give you number of ones. Correct. So you get the idea. So what I'm trying to say is you need not actually have a subarray to hold this window. So you can use mathematics to do some kind of a optimization here. So what I'm saying is you need not actually have the subarray. So you can use this idea where since it's a binary array, you can do some mathematics to get something. So what I'm saying is you have a pointer here, okay, before the start, and you have j pointer, right? So j will be initially pointing to I, right? J will be initially pointing to I, and whenever it's possible, you do j plus plus. So j plus plus is nothing but moving the right side, my right side window, right? So first you do j plus plus. So whenever it's a possible case, you do j plus plus. So j now becomes here. So what is I before 1 and j after 1 means? You are seeing this window, right? And you do j plus plus again. You do j plus plus again because these are all valid cases, right? So when you do j plus plus again, you have one more variable called number of zeros. So right now number of zeros will become 1, correct? Now you do again j plus plus. Now the number of zeros becomes 2, right? Now when you do j plus plus, the number of zeros becomes 3, which is greater than k, right? So in this case, what you do I plus plus. Y means it's a non-favorable case. You move the left side window, correct? So that can be denoted by I plus plus, right? So why this always works is, so till this point, right? Till when j equal to here, this is a valid window, right? So how do you get the size of the valid window? Right. So j minus I is going to give you the size of the valid window. So whenever it's a favorable case, you store the size of the valid window in a maximum variable, correct? Whenever it's unfavorable case, you make it favorable. But you don't do this, store the value in the maximum because it's an unfavorable case. So whenever you have a favorable case, you update the maximum value with j minus I with the maximum. So if the maximum is greater than j minus I, it will remain as such. So size of the window will be j value only when I equal to 0. But after some time, I can become 1, right? So in that case, it will be only j minus I, right? So you get the idea? It will not be always j value. So once I starts moving, then it is dependent on I too, right? So after some time, I will come to 1, right? I will be here. So in this case, j will be here. You can't say that the window size is j, right? Because I has come to one position after it. So it will be always j minus I. You get the idea? Right. So yeah, so this is the approach we are going to do. So we are not actually going to store the array. We're just going to have 2 variables and store the number of zeros. And whenever it's a favorable approach, we are going to store it in the maximum. And after doing everything, you will be having the answer in that maximum. Right. So is everyone clear on what we are going to do? Okay. So I am claiming that this complexity is O of 1, O of n. Right. I am claiming that this complexity is O of n. Right. So the anyone having any other complexities for this approach? Okay, so don't think of it like a for loop. Just think one thing, right? So how many times each element will be seen? So, every time one thing is going to happen, correct? Every time one thing is going, either of these things is going to happen. Either it is going to be j plus plus or a plus plus, correct? So there can be no case where both of these are not going to happen. So either it is going to be I plus plus or j plus plus, meaning every element x will be seen by j once and will be thrown out of the window by I once at max, right? So every element will be seen twice. So once an element goes inside the window, it will not be added inside the window, correct? It can either stay in the window or go outside the window, right? And once element goes outside the window, it will not be added back in the window. If it goes out, it goes out, correct? Meaning every element will be seen only twice. So if every element is seen only twice, you will see every element only twice. So O of 2 and O of n. Right. So as I said, right, you can make the complexity n square by having one for loop. You can make the complexity n by having two for loops also. So number of for loops doesn't mean that the complexity is this. So the best way to find the complexity is how many times you access an element or how many operations you are actually doing. So in this case, I'm either doing j plus plus or I plus plus, right? J plus plus or I plus plus I'm doing, which means that I'm seeing every element, I'm adding element into the window or I'm moving it out of the window, correct? So every element at max can be added or removed, and once an element is added, it will not be added again. Once the element is removed, it will not be added back again, right? Which means I see every element only twice, so the time complexity will be O of n. Is it clear? Right. So yeah. Uh, so any doubts in this? So is everyone clear on what we are going to do here? Right. Okay. So anyone wants a code for this, or can you? Are you planning to try it yourself? You can also try it, but if you want a code for this, I can quickly code it as well. Okay. So since it's the first question, I'll maybe quickly code it, right? But yeah, moving forward, if you want a code or something, we can just discuss, right? Okay. So right now, you came up with an approach, you've frozen upon the approach, and O of n is the best possible solution for this, right? So yeah, so the interviewer is saying that, okay, he's good with the approach. So right now it's only the coding part, right? If you have the code, then yeah, it's great. You can just submit and see whether your code is working. So this question is called a max consecutive ones tree. It's a very famous question, and it's a medium question, right? So you can expect this even in big companies like Google, Amazon, those kind of things, right? I mean, not the same question, but you get the idea, right? Since it's a medium question. Okay. So I hope the code is visible. So it's again, right? So code is subjective. If you have different approach, if you have a smaller approach, you can also code it. Right? So this is something which I'm going to code whatever I said, right? So say this is an interview, and I said one approach earlier. So I'm going to code exactly that, right? So yeah. So I'll start with the code. If you have the code, if you already tried it, please submit and see whether it's working. But yeah, before submitting, please spend some time to find any bug yourself, right? Because in an interview, you can't submit in any compiler. So see whether you can find any bug or any corner case by yourself before the judge says it to you, right? So yeah, so I'm going to have a variable called n as a.length, and I'm going to have the answer as 0, which is going to store the answer, right? Then I'm going to have I equal to 0, j equal to -1, and the number of zeros is 0. Okay. So why is j equal to -1? J denotes after which element it's standing, right? I denotes before which element it's standing, right? So which means if j equal to 0, it means that it is after the 0th element, right? But since at start, 0 will be after the -1th element, I'm taking it as -1, right? But you can mix and match based on your needs. But this is how I visualize, so that it's easy for me, right? So this is the initialization part. Any doubts in this? Okay, I changed array to A. I usually use A, so yeah. Okay, so I hope the initialization is clear. So I just quickly say, so as I said, you will go till the end of the array. So when j is less than or less than equal to less than n, okay, right? So there are two cases. So the favorable case is the number of zeros in the window is less than or equal to k, right? So this is a favorable case. So if number of zeros is less than or equal to k, then you have one approach. Then another thing is another approach, right? Okay. So whenever the number of zeros is in the window is less than or equal to k, what do you do? Right. You do j plus plus, correct? You do j plus plus, right? But there is a small catch here. After you add new element into the window, which element should be updated? Answer is going to store the entire answer. Yeah, answer also will be updated, but you're adding new element into the window, right? What can potentially change? What if the new element added is zero? So which element should be changed? Right. So the new element added can be zero, right? You should always keep track of the number of zeros properly, right? So right. So only if the new element added is zero, the number of zeros I just increment, right? Okay. And again, as someone said, every favorable case is a potential answer for us. Right? So we need not worry about which is better, which is best. You can just have a maximum and then keep storing the maximum so that whenever you get maximum, this guy will take care of it. Correct. So whenever it's a favorable case, it's a potential answer. So increase the size of the window, you add the new element into the window, right? And then you store the answer in the maximum, right? Okay. So this is what we are going to do in the favorable case. Any doubts in this? Yeah, sorry for that. There's some construction going on, so that's why I tried to shut down all the doors, but yeah, I think now it will be better. I mean, okay. So this is a favorable case. So what is the unfavorable case here? So whenever it's unfavorable case, what do you do? Right. So whenever it's an unfavorable case, you do I plus plus. But can you do blindly I plus plus? What is the one thing you have to do before you do I plus plus? So what if the element you are removing is I will be less than or equal to j, I less than or equal to n. I'll say y, okay. But that's not the issue. The issue is, right? The issue is I plus plus. What does it logically say? I need not be less than z. Y means I'll say y. Okay. So even if the number of zeros, so even if k equal to zero, right? The number of zeros at some point will become zero. In that case, j will be ahead of I, right? So you not worry about I being less than j, right? So that will happen because even if number of zeros is zero, or if k equal to zero, this number of zeros will be zero, and this j plus plus will increment, and then in that case, I and j will be equal, right? So that's not the issue. The issue here is I plus plus is removing an element from the array, right, or from the window. What if the removed element is zero? So what should be updated? So in this case, you added a new element. What did you update? You updated the number of zeros. Whenever you remove a new element, before removing, you see whether this value is 0, right? So this value is 0. If this value is 0, you do number of zeros minus 1. Correct. So you never use k, right? You're keeping k as a constant. Why means if you start changing k, next iteration you don't know what the actual k is, right? So you should never mess with k. K should be remaining as constant here. You get the idea, right? If you start changing k, then everything will be messed up because next time you will be using the k, right? So this condition you will not know what was the actual k, right? So that's why we are using this number of zeros. Or else we could have used this k itself, right? Okay. So this is an unfavorable case. In unfavorable case, you remove an element, but before removing an element, you see whether it's 0 and update the number of zeros, right? And in unfavorable case, do you have this line 18 kind of a thing? Will you be having? So should you store the size of the array in unfavorable case? Right. You need not store it because it's an unfavorable case for a reason. So ideally we are done with our solution, correct? So you can just return the answer here, correct? Okay, so I am confident with this code. If you have any issues with this code, you can find. If you have any corner cases which I might have missed, you can find. Okay, can we submit this code? Why I am giving this extra time is when you say that you are done, you should be done. You shouldn't have missed any corner cases. So right now you should be thinking on where there can be some issues, right? So should you do this check here, j less than n check here, because we are already doing it here, right? So this is this check needed here? I got one yes and one no. Interesting. So right. So what if j equal to n minus 1 here, right? So what will happen is j will become n here. So if you don't do this check, you'll be directly accessing the nth element, which is going to cause index out of bound exception, correct? So this check is important here. Right. So yeah, so this check is actually important here, right? So when can this happen? Say everything is 1 and k is 0. So always it will go inside this if case, correct? No, sorry, k is some 1000 and all the entire input array is 1. So which means the number of zeros will always be less than or equal to k. So it will be keep on going again and again and again, right? So when j becomes n, you'll be trying to access the nth element. So there'll be issues here, right? But yeah, it depends on how we code. So if you code it in some other way, you need not handle this. But since we are coded like this, we are handling it here, right? So depending on how you are coding, you can, but you can't control how you are coding in an interview. Right? So whatever is coming on that way, you just try to. So whenever you code in an interview, don't think too much about I'll have to write a very short code or something. So usually it will take some time to optimize. So people usually write a long code and then make it shorter, right? So in an interview, just go with the flow, but make sure that you are in that moment so that you handle cases like this, right? So maybe the same question some other day you'll be doing it in different approach, but don't think on what all conditions I added in the previous approach because this is a new approach, right? So in this point of time, you just think, okay, what are the conditions I should satisfy so that it always works. Okay, so I think I have covered everything. Let's just run the code so that we don't get any compilation error. Okay. Okay, we got accepted, right? Or did I run? Okay, yeah, we got accepted. 17 10 21. Yeah. Okay. So this is a working solution. So can everyone understand how this is O of n now after seeing the code? Because we either do j plus plus or I plus plus. We never have a case where we don't do both, right? Which means every element is either added into the worst case, right? The worst case, either it's added into the window or removed from the window, right? Which means there are only two operations for everything. And you don't go back in time, meaning once you add an element into the window, you don't add it back, right? So yeah, because of all these reasons, this comes down to O of n, right? And since it is O of n, it if you see, right, the size of the array can be at max 10 power 5. It worked because only if it's O of n. If it had been n square, you know the reason, right? So it would have taken 28 hours, and this compiler is not going to wait for that much time. It will say time limit exceeded, right? So if you try to submit the previous approach here, it will say time limit exceeded because it would have been O of n square. And you know, if 10 power 5 is the number of the input, usually C++ can do 10 power 5 iterations in 1 second, usually, right? It's not like fixed number, but yeah, a safe number is 10 power 5, which means that your previous approach will take close to, one day to finish. So now you get the idea of how the previous approach on paper looked nice, right? But you get the idea on how much optimizations we have done because of, adding some extra variables and other things. And we are not even using any O of n space. The space still remains O of 1, correct? So yeah. So this is a sliding window. So most of the questions will be very similar to this, where you'll be having some condition. You have to find what is favorable, what is unfavorable. You just have to slide through the array, right? And to be honest, this concept is not a very easy concept. There'll be easy, or there'll be only medium or hard questions in this. Very rarely you can get easy questions, but mostly it will be medium or medium hard or hard. Okay? So yeah. Any doubts in this overall, or any doubts in this approach as such overall? Okay, so this is one way of doing it. So I just added a few variables here. So I is going to store the left side of the window, J is going to store the right side of the window, and I have number of zeros to store the number of zeros. So this zeros will say whether the number of zeros in this window is exhausted or I still have something by comparing it with K, right? So I'm going to write a while loop, right? While J is less than N, while the right side window, uh, while the right side window is less than N. So why J equal to -1? So in my definition, I starts before the index, J denotes after the index, right? So say you have this array, okay? Say you have this array, I will be here, J will be here, okay? So which means if you have one element this here, J will also be 0, I will also be 0. So in this is my way of defining it, right? Which means J is after the 0th index. I is before the 0th index. But at the start, since it's empty, J is -1. J is after the -1th index, which is starting of the 0th index. I is also starting of the 0th index, right? So this is my way of defining I and J. You get the idea? So if you want, you can do, you can also mix and match. You can also denote it like I starts before the index, J starts before the next index, right? So in that case, you can have J equal to 0, I equal to 0, but you have to change all the algorithm based on these values, and you have to add few things here and there, right? So you go till the end of the array. You have only two cases, favorable and unfavorable. The number of zeros you have is less than or equal to k in the given window. You increase the size of the window, but whenever you increase the size of the window, you're adding new element. This new element can be 0, so you have to update the number of zeros. But you can't directly go and see this value because at some time it can be greater than or equal to n. So you have to say that is less than or equal to n, and if the new value added is 0, then you update the number of zeros, right? Then you also keep track of the answer because any favorable case is a potential answer. Any unfavorable case, you remove the element, but you can't blindly remove the element because the removed element can be 0. So you check whether the removed element is 0, and then you reduce the number of zeros, right? So after doing everything, the answer will be having the answer. So you can just return the answer. Okay, so most of the questions will be somewhat similar, but how do you know whether the question is sliding window question? So if the question is saying what is the maximum subarray, what is the maximum minimum subarray, those kind of subarray kind of a thing can be sliding window. I'm not saying it's always sliding window, but you get the idea, right? If the question is not at all subarray somewhere, if you can sort the array or something, then it's not a sliding window, right? Maybe after sorting, you can be like you can use sliding window, but you get the idea, right? So yeah. So whenever there is a subarray kind of a question, your mind can kind of think, okay, so yeah, whether you can use sliding window or not, right? So yeah, so with this, I'm closing actually sliding window. It's not a very algorithm or a very big thing. It's just a technique, but usually people usually don't discuss it broadly because people think that candidates usually learn it by themselves. But it's a bit trickier if you it's a bit trickier to learn it by yourself. So yeah, I just thought of adding it in the session, right? So we'll have a maybe, yeah. Okay, so I'll share the slide link. Okay, so the slide has the question and the answer. The question is here, the answer is here. Okay, so slide is this one, and sorry. Yeah, initially it is difficult because if you see, right, the question itself is falling in difficult or medium, hard or medium thing, right? So yeah, that's why I thought of covering. So after you solve 2 3 problems, you'll be able to understand it end to end, right? I mean, understand as in it will not be difficult anymore. Okay, so I added the slide and the feedback link. So it's 10:28. I think we can meet back at 10:35, and then we'll just kind of start with linked list. But we'll see the entire linked list tomorrow only. But yeah, we'll kind of start with linked list today. So yeah, so have a water break or something, and then kindly give feedback. And I also attach slide link. So yeah, we'll meet at 10:35 again. Okay, I think we can continue the session. Yeah, maybe a minute. I'll share my screen again. Okay. So I just given few things on what is sliding window and other things. Usually it's not very needed because it's not a very theoretical concept, more like a technique kind of a thing. So yeah. So I just added one question, and for people who already know sliding window, I added one tougher problem, but you know, right? So there are lots of resources, so I can just go through. So I also added 2 homework problems, so please do try these 2. For one, I already added the link here. So if you have a question, you can go and submit this question and see whether it's working, right? But the thing is, mm, I'm giving from late code so that you don't because in code kata the question number will differ, right? So I'll have one question number, you'll have one question number. So that's why it's difficult to give a question from code kata because everyone will be having different question numbers and I can't like properly say this is the question. But yeah, you get the idea, right? So practice a lot of things. So once you practice 4 or 5 problems, after that automatically you will start solving problems which are similar, right? So this 1 and 2 is again medium problems only, not a very difficult one. This is a tougher problem. Summary with K different. The tougher part is not implementation part, but more like a thinking part, right? So yeah. So this I'm closing sliding window. So we'll just see linked list. We'll just see what is the difference between linked list and what is when can you use arrays and when can you use linked list. Only that part today. We'll start linked list fresh from tomorrow. I have added few items to study. So before coming to next class, please do go through these 2 links alone so that we both are on the same page. Okay. So yeah, so to understand linked list, we need to understand how memory works behind the scenes. Okay. So what is memory working behind the scenes? Okay. So what happens is, as you all know, a computer will be having, or your computer will be having some fixed memory, correct? So some fixed memory in its system, right? So when you define an array of size 100, okay, when you define an array of size 100, so what happens is when you say I want array of size 100, so what happens behind the scenes is compiler will go and assign 100 memory spaces in the 100 memory spaces maybe of size integer, okay? 100 memory spaces of integer in this memory space, right? And it will be continuous, right? So what is continuous? Say the address, usually there will be address for each part in the memory, right? So each part in memory will have some address. So if you have studied if you're from EC, triple E, CS, IT background, you might have used that 8086, 8085 IC and other things, right? So in those cases, I think you would have had a lab or something. If you're not from that thing, it's fine. But if you have been in those courses, you would have had a 8086 or 8085 thing, and you'll go and store things in the address and you'll retrieve it from it, right? So that's what actually happens behind the scenes, right? So there'll be address at every point in memory, right? So that address will be in hexadecimal, but for simplicity, I'll make it as integer, okay? So say that address is starting at 4000, okay? Address is starting at 4000 and say this is a 32-bit integer, okay? So this is 32-bit integer, right? So what happens is every element will take 4 bytes, okay? So every element will take 4 bytes. Say you have 100 memory spaces. If the address is starting at 4000, so 4000 to 4003, 4000 to 4003 will store the first index, 0th index. 4004 to 4007 will store the first index, and so on, right? So what happens is 4400 or something will be storing the last index. 4397 to 4400 will be storing the 99th index, right? So that's how the memory will be allocated. What I'm trying to say is it will be continuous in memory allocation. Like it will not be split into multiple parts, right? So that's how this array works behind the scenes, right? So this is what array will happen. So it will start from address, and if every element is taking 4 bytes, for every 4 byte there'll be one index, correct? And it will be continuous in memory space, right? So that's why in an array, right? In an array, if you want array of fifth element, you will put it as array of 4, right? So what is the time complexity of getting the fifth element from an array? So if you want to get an element from the array, what is the complexity of it? It is O of 1, correct? So why it is O of 1 means what happens behind the scenes is the compiler will go and, okay, this array's base address is 4000. That it will be storing it somewhere, okay? And you want the fifth index. So what it will do is 4 into 5, right? Or if you want the fourth index, right? So 4 into 4, right? So what is this for? This for is the number of bytes of each element. For integer, if you store 32-bit integer, it's a 4-byte value, right? And 4 is the fourth index you want, correct? So base address plus 4 into 4, right? And this will give you 4016. Okay, 4 4s are 16, right? No, yeah, 16. So 4016, which means from 4016 to 4019, you will be having this value you have, fourth element, right? So 4016 is the starting point of the fifth index value, right? So that's why this is O of 1. You get the idea. So accessing an element directly accessing an element is O of 1 for this use case, because at the back end it's just addition and multiplication, correct? And this is possible only because elements are stored in continuous fashion in an array. So if it is not being stored in continuous fashion in array, then this is not possible, correct? So yeah, so that's the basic idea. So yeah. Okay. So this is a basic idea behind the scenes. So that's why accessing element in array is O of 1, because behind the scenes is just mathematics. Okay. So yeah, so coming back, this is arrays, right? So the advantage of this array is the accessing is O of 1, right? So accessing is O of 1, right? But there is a small disadvantage there, right? So this entire memory space is not available only for the code you run, right? So there can be a Google Chrome tab which is running behind the scenes that will take some memory. There'll be one IDE which is running, which is take some memory. Your music app is going to take some memory, and so on, right? So what is going to happen is when you want say 10,000, okay, very huge array size of 10,000 at the start itself, right? So what will happen is this compiler will go and search, okay, is there 1,000 memory spaces, 10,000 memory spaces available continuously, because since it's an array, right? So continuously. So it will go and check here. There'll be only say nine spaces available. So the space is not available. Then it will go check here, and only after checking here, okay, it will say it's available. Right. So the compiler is going to take some time, right? So it will not be very, significant time, maybe in terms of microsecond or nanosecond. Okay. Not nanosecond, microsecond. Okay. So in microsecond, it will be. So this microsecond time will be taken by this compiler to allocate continuous memory spaces. Why means memory will be randomly allocated and it will be used by multiple applications, right? So to find a continuous memory space, especially if the array size is very large, it's going to take some time for the compiler, right? So that's why they came up with this approach. And one more thing is, in real world, you don't know the real size of the array, correct? So for simplicity, for our program, we can use this. But in real world, you don't know the real size of the array, right? So that's why they came up with the concept of linked list. So what they're going to do is, whenever a new element comes into the picture, they'll just add that element. So initially, this is the space. Initially, there is no element in this linked list, right? So when the first element comes, say that these memories are already occupied by some other applications, right? So when the first element comes, it will go and allocate whatever is the first possible 4 bytes, not the entire array. In an array case, entire array should be continuous. But in linked list, for that element alone, that space will be allocated wherever it's possible. Next time, one more space will be allocated. Next time, one more space will be allocated. Next time, one more space will be allocated, right? So this is the advantage of linked list, meaning this allocation time will be much faster. So whenever you want a new space, this allocation time will be much faster. But there is a small catch here, right? The catch is, how do you know that the ones in red are belonging to the same element or to the same array? In array case, it's continuous. So even if you randomly access anything here, you know that this belongs to array, correct? But how do you know that? And you also know where the array is starting based on the base address. And if you want to access everything in the array, you can just go one over. But here you don't know where the next element is, correct? So whenever you access here, it just exists here. But how do you know these two belong to the same data? Because there can be one more linked list in some other thing which is using some other data. So how do you know that just black and red are not part of same data, right? So that's why what they do is they link these elements. So how do they link? Okay, after this is the next part. After this is the next part. After this is the next part, right? So this is how they link the elements in the memory space. So that's why it's called a linked list, right? So this entire thing is actually called a list. Okay. So, and since it is linked one on top of the other and it's not continuous in memory space, it's called a linked list, right? So this is how the name came, right? So practical usage, one thing is in gaming industry and all, right? This allocation time also matters, right? So allocation time in real world also matters because in gaming industry if you play any game, right, there'll be a lot of frame things happening. So 60 frame per second, 90 frame per second should be loaded, and for those the extra memory space is needed. So if you take the number of hits the RAM takes whenever you play a game, there'll be a lot of hits on the RAM. Meaning, whenever you go to a new location in the game, right, the older location will be cleaned up from the RAM and new location will be loaded. You get the idea, right? So yeah, so a lot of allocation will be happening behind the scenes, and this allocation time, even in microseconds, is going to cause some lag in the gameplay, right? So that's why in gaming industry and all they use this linked list, right? So that the allocation is much faster. But the problem is in array, if you want to access the fifth element, you can directly put array of 4. But here you can't put list of 4 directly. Why? Means this is not continuous in memory space. So compiler does not even know where the fifth element is. So you can go only one by one. So which means if you want to access any nth element in the linked list, it is going to be O of n, right? But here, if you want to access any nth element, it will be O of 1 because you can directly go and put array of n-1, correct? So that's the difference, contrast, and that's a similarity and contrast between arrays and linked list, right? So this is theoretical part of it. From interview point of view, uh, linked list, since it has this extra condition, right, compared to array, and accessing linked list and managing linked list and all is much more difficult than array because array everything will be done by the compiler for you. Linked list you have to manage everything. So because of this reason, there can be linked list questions in interviews also, right? So interviews, they can also ask linked list question because it is making the question even more complicated, correct? And it will make you a bit confusing even after some time. So yeah, so it's always in interview point of view, linked list is asked a lot because of these reasons, because it's more confusing. So yeah, so this is the basic difference between arrays and linked list. If you want to have if you want to have a practical comparison, you can just yeah, you can just Google and see what is a practical usage. One thing I definitely know is the gaming industry that they prefer linked list for some operations, not everything. The core operations they prefer linked list, right? So yeah, so this is a basic difference between arrays and linked list, right? So I have added one more link from Geeks for Geeks where they would have mentioned this, but everything will be boiled down into one point, which is in array you can access the random element. In linked list you can't randomly access any element directly. You have to go through every element once, right? So yeah, so this is what I wanted to cover for today's class. Any doubts in linked list? Okay, great. So then I'll be closing today's class today now. So I didn't want to, I didn't want to start with linked list because once you start, it's going to take some time. So yeah, so tomorrow you can again start with linked list. Meanwhile, what you can do is you can questions. You can try implementing by yourself. If you already implemented Nicholas, you can just tell me what is the difference and maybe how. So has everyone gone through the OOPS class, or you are yet to go through that OOPS class? Like OOPS has been taught to you. Okay. So in this, so what you can do is in this linked list, I'll just teach one concept of OOPS, right? So that you can brush it up later, but I'll just teach one concept of OOPS, which is class and how to create objects and what is object and those kind of things. But I think once you start reading OOPS, you'll have a better idea on what is object and other things. So for now, you can just abstract out that part alone, right? But yeah, so for this JavaScript, I mean, linked list alone, you want OOPS because I don't want to teach you without the OOPS because the OOPS adds a lot of, a lot of value there. So yeah. So yeah, so with this, I'm closing today's class. Okay, so someone wants. So this is a very so why I didn't give you link for this is so in an interview, right? If you go to this link and see the question, it will be elaborate. But in interview, it will not be much more elaborate. So that's why I didn't want to add the solution. But again, I'll try to find this. This is also a very famous question. So yeah, I'll add the link here once I find it. But I would prefer you going through this statement and then coming up with the solution, because in an interview it will not be as clear as the one in the problem statement in this link, right? So yeah, it's not like something I found out. So yeah, I'll add the link here once I find out. Okay, so I'll just share the slide link. If you don't have any doubts, you can feel free to drop off. Thank you, everyone.